All right. Let's go ahead and get started. Hopefully everybody's doing good. You all had a good weekend. We are halfway through Unit 3. So kudos to you. I know that it's been very challenging for you all and for me too, because quite frankly, I do miss you all and being up at the school. And sometimes when I do go up there and check in from time to time, it's good to see that you guys are doing well, and most of you all are still on top of what you're doing. So good job on that, and keep up the good work. So we're gonna go ahead and move to lesson 5. So if you remember, there are 8 lessons altogether in Unit 3. So now that we're on lesson 5, we are moving past the halfway point. All right. So throughout the first 4 lessons of Unit 3. We've been looking at exponential functions. So we've looked at examples on graphing, finding characteristics of the graphs, and we've been doing all these other things as well. So what we're going to look at today, or starting today, is the other type of function, because remember at the beginning we said we're going to look at 2 functions in this unit. So the second function that we're going to look at starting today is something that is called a logarithm. All right, so we're going to start on page 18 of our packets. So go ahead and move to page 18, and that is where you're going to find lesson 5, like what I have here. So we're going to introduce today what is a logarithmic function, aka a logarithm. So by the end of this lesson, you'll be able to not only look at and express how they look, but also you'll be able to kind of go back and forth between a logarithm and an exponential function. You'll kind of see that they kind of go side by side. And so that's what we're going to be focusing on during this lesson for today. Okay, so our do now is actually something that we're going to do together because it's kind of introducing the notes of what we're going to be talking about today. All right, so logarithms. Again, this is a new type of function, and the good thing about them is that it's nothing too complicated. In fact, logarithms are another way to write exponential equations, so things that we've seen before. Okay, so here's an example of an exponential function. We have a number raised to a power, right? So in this case, we have 2 raised to the fourth power. We already know that 2 raised to the fourth power is equal to 16. Okay, so we can plug that in our calculator, or if you don't remember, 2 to the fourth power is the same as 2 times 2 times 2 times 2. We're basically multiplying 2 by itself 4 times, and that's how we get 16. All right. But we can say all of this and we can rewrite all of this in terms of a logarithm. Okay. So, how instead of saying 2 raised to the fourth power equals 16, how we say that in terms of a logarithm is log base 2 of 16 equals 4. Okay. So when we're looking at logarithms or looking at expressions similar to what we see here, what we're trying to really just answer or think to ourselves is that we're trying to figure out 2 raised to what power will give me 16. And in this case, it's 4 because we already just figured that out over here. Okay. So that's how logarithms work. It's basically trying to figure out whatever this base is, we're trying to figure out what exponent can we raise this base by to get the number that is inside of our logarithm. So that's kind of like how we're trying to think of it moving forward. Okay. So in general, this is how logarithms are written out. All right, so we have a log with a base of some number we'll call b. Inside of our logarithm, this is our value, and this is equal to c, which is representing our exponent. Okay, so these variables, they do have meaning, so we're going to give some context behind it. So looking at this, because we can convert a logarithm to an exponent, so you can see that a, b, and c here correspond to a, b, and c here. All right, so b is your base, C is your exponent, and A is your value. Okay, so any logarithm that we have, just like what we have here, you can rewrite it as an exponential function. So how you rewrite it is that you take your base, which is here, this is your exponent, and it's going to equal whatever is inside of your logarithm, inside of your parentheses. Okay. Now, there are a couple of specific or special logarithms that I do want to cover. So that way, if you see it moving forward, you know what is going on. All right. So the most common logarithm that is out there is normally when we have a logarithm with a base of 10. All right. So if you have a logarithm that has a base of 10, typically sometimes what might happen is you might see problems written like this. All right, so you can see here that we just have log of x. There's no base here. All right, so this is telling you that if no base is provided, you can automatically assume that it is the number 10. All right, so I'm going to leave a note there for you all, and I would suggest writing it in for you as well. Just say that if no base for your logarithms, just assume it is 10. All right, so that's just something for you all moving forward in case if you see that. All right, so that's the first type, and that's again the most common logarithm that is out there. The second one is something that is called a natural logarithm. So a natural logarithm, that happens when your base is actually the number e. Now, if you remember, the number e is a special number because remember this is what we called Euler's number. We looked at that a couple of lessons ago. So we're still using it here. Now, while this is true, if you have a base of E or a base of Euler's number, you can write it as this way. But typically what might be shown is that another way you can show this natural logarithm is that they might write it as ln x. Okay. So if you see something written like this, where it says lnx, that is the same as having a logarithm where your base is Euler's number or e. Okay, so they're both one and the same. Now, what we're going to try to do first is that we're just trying to get some practice with converting from exponential form to logarithmic form. Okay, so what we're going to try to do is that if we see an expression or an equation written as an exponential form, we're going to convert that and rewrite it as a logarithm. And then we're going to do vice versa as well. So we're going to look at a couple of these examples down here together. All right. So we have an equation here. We say here 9 squared is equal to 81. That's an exponential form. So we want to say the same exact thing, but we want to rewrite it in terms of a logarithm. Okay, so we're going to use this tactic up here, and that is going to be our guideline in terms of how we're going to write our logarithm. So we're going to start by writing log. Now we need to identify our base. Our base in this case is 9. So we have a log with a base of 9. Then I'm going to write my value, where my value is that number by itself on the right-hand side, which in this case is 81. So we have log base 9 of 81 equals whatever your exponent is, which in this case, our exponent is 2. So this is how we can write an exponential equation in terms of a logarithm. Now, you still got 3 more here. So I want you to just try to see if you can rewrite each of these 3 expressions in terms of the opposite. And once you unpause this video, you're going to see the answers that I provide so you can check for yourselves to see if you're on the right track or that this is an opportunity for you to ask more questions after the video. So go ahead and pause it at this time. All right, we are back. And here are the answers for the other three example problems listed here. So for the first one, you should have rewritten it as log base 8 of 1/64 is equal to -2. All right, so this is your base, that is your value, and this is your exponent. For this problem, we had a logarithm and we had to rewrite it as an exponential equation. Now, you might have noticed here that for this logarithm, there was no base provided to you. And so just like what we wrote up here, we said if no base is given, that means that we need to assume that it is equal to 10. So in this case here, if I want to write it as an exponential form, we're going to say our base, which is 10, raised to our exponent, which in this case is 2, is equal to our value inside of our logarithm, which in this case is 100. So that's how we have 10 squared is equal to 100. Now, for this last one, you have e to the power of x is equal to 8. So we need to write that as a logarithm. All right. So in this case here, log, your base is e, your value inside of it is going to be 8, and that equals your exponent, which is equal to x. So you can rewrite it in this form, or just like what we looked at above, if you have a logarithm with the base of e, instead of writing all of this, you can just use the natural log. So that's what I did here. So all I just did is that just change this out, this log base e, and replaced it with the natural log. And that still gives you the same thing. So this is how we go about going back and forth with converting from exponential form to logarithmic form. So this is going to be a good practice for us, and we're going to continue looking at this throughout this lesson for today. But I'm going to go ahead and for now move forward, and we're going to go ahead and move to page 19. So now we're still going to be using these this concept of logarithms and kind of converting it to exponential forms. And this will be helpful for us when we're trying to solve for logarithms algebraically. So we have an example up here where it says you have the log base 4 is equal to x, and we're trying to figure out what is that number for x. Like, what is this value? Okay. So if I want to figure out what x is equal to, what I would suggest first is that I would say let's write this out in exponential form. Okay, so if we want to write this out in exponential form, same idea, we're going to go back to our notes from page 18. So we start with our base, which in this case is 4, raised to our exponent, which is that number on the right side. We don't know it, so we're just going to write x, is equal to our value inside of our logarithm, which is 64. So in other words, if we're trying to solve for x in this equation, we need to figure out 4 raised to what power is going to give me 64. So this is something where you might want to, test this out on your own, or you might have to play around with it. You might do like 4 times 4, which is 16. So you realize, okay, this doesn't work. But if I did 4 times 4 times 4, that in fact does equal 64. Okay, so I multiplied 4 by itself 3 times. So this tells me that my exponent is 3. So in other words, log base 4 of 64 is equal to 3. Okay, so that is how we solve for logarithms algebraically. It's going to be helpful for us to write your equation out in exponential form, because then that will be like a little insight in terms of, okay, what do I need to do to figure this out? Now we do have a couple of other examples that we're going to do together as well that I wanted to show us also. All right. So the first one, you have log base with a base of 64. We're going to change this number. This is a mistake. This should not be 243. We're going to use the number 4096. Why that was there, no clue, but I apologize for that mistake. Okay, so we have log base 64 of 4096 is equal to x. Same idea as above. We're trying to figure out what number for x can we substitute to make this equation true. So, like we did before, we're going to write this in exponential form. So 64 is your base. I'm going to start with that. And my exponent is x. We don't know that. And this equals 4096. Now, if you have a calculator on standby, this will be very helpful for you, in which you can kind of toy around and see, and just kind of plug in some different numbers to see 64 raised to what is going to give you 4096. And it actually turns out that if you just did 64 squared, you would get 4096. So that means that in this example, x is equal to 2. Pretty straightforward, very similar to the example that we did at the top. Now, for part B, okay, we're going to try this again, this time still using exponential form to figure out our value for x. So in this example, our base is 4, exponent is x, and this equals 1 over 16. Now, this is a little bit different than what we have done in these first two examples so far. Now, you might think to yourself, well, hey, Mr. Green, I know that 4 to the second power, that gives me 16. That is true. The problem in this case is that I have 1 over 16. All right, so we need to do something to this to make this true. Well, take me back for a second. I know that 4 squared is equal to 16, yes, but what if I had 4 to the negative second power? Now, in our last lesson, we looked at what happens or how we can deal with when we have exponents that are negative. We said from that last lesson that if we have an exponent that is negative, what we need to do is that we need to write this as a fraction, where we have 1 on the top and we write 4 squared, in this case, on the bottom. Right? That's what we talked about. That's one of the rules about exponents from our last our last lesson. Now, on the bottom here, we said, well, okay, well, 4 squared is equal to 16. So really what I have here is 1 over 16, which is what I wanted from the start. So this means here in our case that our exponent is going to be negative 2. So this should tell you, or this is just giving you insight that if your value is a fraction, just like what we have here, that means that your x or your exponent is going to be negative. Okay. Now, for this last example, we have log base 64 of 8 is equal to x. Okay, and so still same idea. We want to still set this up in exponential form. In this case, all right, we got 64 because that is our base. Our exponent is x, we don't know that, is equal to our value, which in this case is 8. So we're trying to figure out 64 raised to what power is 8. All right, now couple things. We might know that, okay, well, hey, I know that 8 squared, I know that is equal to 64, but I'm kind of going backwards in this case because I'm doing 64 raised to some power is going to give me 8. You might also remember that the square root of 64 is equal to 8. Remember from way back, I believe in Unit 2, when we were dealing with perfect square roots, square root of 64 is a perfect square root. In fact, like I said, this equals 8. So square root is the same thing as an exponent of 1/2. So in this case here, our exponent is 1/2. Now, if you didn't know this part and you just remember that, okay, 8 squared is equal to 64, if I'm going backwards, then all I just need to do is just pretty much write this or take the inverse of it. So instead of 2, the inverse is 1/2. So that's how I can go backwards in getting to this answer here if I want to. Okay, so I'm showing all these examples just to show that while you can find out all these answers using exponential form, you're going to get some different values in each case. So it's going to be, important for you all to kind of remember, your tips and tricks with exponents and also just some simple math pieces as well that we've talked about in the class before I went on paternity leave. Now, this is how you could do it algebraically. These are all the steps that you need to do. Now, I know that some of us prefer not to always have to use algebra, even though this is advanced algebra, yes. And sometimes we might want a cheat code, and that's completely fine. So, if we want to use a cheat code, calculators will be that cheat code. That is how we can get to finding these answers a lot faster. So, main thing, how can we use a calculator to find all these logarithms? All right, so we have a couple of examples listed here. The first one that we're going to look at is the log of 222. So I'm going to move away from my notes for 1 second, and I'm actually going to share my screen. So let me change this out for us. Give me 1 second. And now we're going to share. I'm going to share my screen. Okay, so we are looking at how we can type this on our calculator. Now, we can't see that, so I'm going to zoom in and try to see if I can zoom in as much as possible. Okay, hopefully we can all see this on our screens. But if we want to type log 222, there is a log button on your calculator. In fact, it is right beneath that green button on the top left corner. All right, so all you just got to do is just type log, put your number 222, close it out, and if you hit enter, it gives you an answer. It tells you in this case, okay, log 222 is 2 point, I'm going to round 2.35. So pretty straightforward, all right? Now, the next problem, you had natural log of 14. So same idea, if you look right beneath that, you see natural log, ln, okay? So we're going to use that. We're going to type ln, and then we're going to do 14. Close that out. And if we enter, in this case, we get 2 point, I'm going to round up, we're going to say 2.64. So that's the natural log of 14. Now, these two are pretty straightforward, and these two are like, hey, okay, I can do that. I got a calculator that tells me that. But if you look at the bottom of page 19, you have an example there that says you have the log with a base of 2 of 50. And we're trying to figure out what that equals. Okay, so this is where I'm going to stop sharing just for one moment, and I'm going to go back to this. Okay, so I have log base 2 of 50, and I want to figure out what that equals. Okay, if you have a logarithm with a base that is not equal to 10, all right, there's like one additional step that you have to do in order to get to your answer. All right, so how you do that, or what you need to do, is that what you want to do, we're going to follow this right here. We're going to take the log of our value, we're going to divide that by the log of our base. So looking at this example here, if I want to plug this into my calculator, what I need to do is that I need to do the log of 50 divided by the log of 2. If I plug this into my calculator, this will give me the correct answer for this logarithm up here. Okay, so if I go back to, if we go back to our calculator here, all right, here's our calculator. If we want to figure out what this is, we just need to type in log of 50, close that out, divided by log of 2. Let's close that out. And that tells us, okay, our answer here is 5.64. Okay, and that is our answer for this problem. Now, just another example, I'm just going to give us an extra one here. Let's say that you wanted to find, I don't know, let's say you wanted to do log base 5 of 90. Let's say you want to figure out what this equals to. All right, so what I would do in my calculator is that I would type in the log of 90 divided by the log of 5. Okay, so if we go back to that, all right, log of 90, close that out, divided by log of 5, close that out. What we get as our answer is 2 point, and I'm just going to round up, we're going to say 2.80. Now, we use logarithm for both of these examples. What if we decided to change it up? What if we wanted to do, or what if we used the natural log? Meaning, what if I did natural log of 90 divided by the natural log of 5? If I were to, type this in my calculator, what actually turns out, or what actually happens, is that you get the same answer. So this is just telling us that no matter if I use logarithm or natural log for my calculator, as long as I'm using both of them for both numbers, I'm going to come across the same answer. So what I mean by that is that I can't type in log of 90 divided by the natural log of, divided by the natural log of 5. Because if I'm changing it up and mixing it up, as you can see here, you're going to get a different answer altogether. So be consistent. You're either going to use the natural log for both numbers, or you're going to use the regular log button for both numbers. Don't mix it up. All right. Let's go ahead and stop sharing. So we just saw here that even if I typed in the natural log of 90 divided by the natural log of 5, I still come across the same answer. And that's where this comes into play here. So this is what we call our change of base formula. And this will be helpful for us, especially if we have our calculators on standby, in terms of trying to figure out what are those logarithms like this here, where you have a base outside of the typical common 10 or Euler number. All right, so we're almost done with the lesson for today. Now, the before you get into independent practice, I do want us to do, there are a couple of examples here at the top of page 20 where you need to compute each of these 3 logarithms. All right, so take a few moments, go ahead and pause the video, use your calculator to help you with figuring out what are finding the values for each of these 3 logarithms provided. So stop the video, and then when you unpause it, you will see the answers to each of these momentarily. All right, so here are the answer for the check for understanding problems at the top of page 20. The log of 82 is equal to 1.91. The natural log of 106 is equal to 4.66. For part C, where you had the log base 3 of 68, if I want to figure out what this is equal to, I need to use the change of base formula from before. So if I want to use my calculator, I need to type in the log of 68, divide that by the log of 3. And if I did that correctly, you should get 3.84 as your final answer. All right, so that is how we can use our calculators to our benefit in terms of finding any logarithm that is given to us, no matter what the base is. So we actually, believe it or not, covered a lot in this lesson. We looked at how we can go back and forth from converting exponential functions to logarithms and vice versa. We've looked at how we can find and calculate logarithms algebraically without a calculator. And we've also looked at problems on how we can find a logarithm with using a calculator if need be. So you will see for the rest of page 20 here, you have practice problems that cover every part of this lesson that we've talked about today. So you have a couple problems, questions 1 through 6 here, that look at practicing going back and forth between exponential form and logarithmic form. You have questions 7 through 9 here, asking you to find your values for x algebraically without using a calculator. That's the important thing. So you need to find these answers without using a calculator. And then the last problem here, number 10, this is where I'm allowing you to try to solve for this problem with using a calculator. So this is your assignment for today. You have these 10 problems here provided. Now, I know at the bottom of page 20, I did say that there is an exit ticket that you need to complete on Illuminate. Good news, there is none. So there is no exit ticket for lesson 5. You will see that when you finish lesson 6 later on in the week, I created the exit ticket for that, where it kind of combines everything from that lesson and from the lesson from today. So you do not have to worry about having to complete this um, after this video. All you need to worry about for today is making sure that you get these 10 problems here knocked out. So consider this your assignment. You need to make sure that you're spending the rest of class time today to make sure that you get these 10 problems here knocked out before the next class period. All right. When we do meet again later on in the week, whether that's Wednesday or Thursday, this will be checked to make sure that you have it completed. So you need to make sure that you have it done. All right. Because you never know. I might pull up there and I might check myself. So just be on standby and make sure it's done. All right. So this is this is lesson 5. So this is now we are getting into the second half of unit 3, where we're talking about exponential functions. So now at this point, all right, you guys have your assignment. You guys know what you need to do by the next time we meet. And so if you do have questions about those independent practice problems that I did provide, or if you want to check to see if your answers are on the right track and seeing that you know what you're doing, please feel free to reach out to me at any time. I'm happy to get on with you all through Zoom to make sure that we're on the right track, or you can always feel free to just email me or text me like you normally have been doing. All right. But otherwise, enjoy the rest of your day. Make sure, again, you get those problems knocked out. So that way, when you come back in for your next lesson, those are completed and we can get you checked off for that. Otherwise, have a great rest of your day, and I will see you next time.